for example, I have two service providers. Let's say one Verizon and AT&T. In Verizon, one IP is coming up, okay? And we talked about it will send a broadcast message and collect the data. It is going to take a longer time to do that. Instead of these network providers, right, these ISPs will transfer the route information within them using a protocol called BGP. That's called Border Gateway Protocol. So they will exchange the route information before instead of going and manually doing the broadcast and getting the information, they will get the routing informations used or exchanged between two ISPs using the Border Gateway Protocol. So this is what the terminologies are used. The reason why I explained this terminology is using these terminologies, I am going to explain some of the network providers of the Kubernetes. Okay, so the first network provider I'm going to talk about here is called Flannel. Okay, so let's say I have a container A running on a Docker host 1 and I have a container B running on the Docker host 2. When it wants to communicate to the container B, okay, so what really happens is there will be an overlay network created between these two containers. That is where the Flannel comes into picture. This Flannel will have the informations about all the machines which are connected to the cluster. Okay, let it be any network provider, there will be a network provider component that will be running on node. So let's say in our Kubernetes cluster, there will be one Flannel component will be running on all the nodes which are connected to my machine, right? So what happens is if container A wants to communicate to the container B, so what it will do, it will using, let's say the container A is having an IP address of 10.0.0.1. In the overlay network, this is the IP allocated for the container. If it wants to communicate to the container B, there is no direct connection available here. It has to come to the physical interface. Only via the physical interface it can go there. From there it can reach the container B. So what really happens is this container A will create a packet. In the packet, Flannel will do the encapsulation, saying that it will hide the 10.0 IP and also it will attach the public IP of the machine. Like let's say 192.168.1.10 is the IP. So it will embed the IP into this and the packet will be sent out. Okay. And in the normal network, it will send a broadcast message to all the interfaces. Okay. And then the Flannel on the receiving node will receive the packet and it will extract the source IP. Let's say the container IP is, which it wants to connect is 10.0.0.2. So this Flannel will know I am hosting a container with the IP 10.0.0.2. Then I will send a success message. Okay. And this will go ahead and update my routing table saying hereafter, if I want to connect to the container B, that is 10.0.0.2, I should connect to this machine that is 192.168.1.11. Okay. So using this encapsulation method and overlay network, it basically broadcasts the information, and based on that response I'm going to get, I'm going to update my routing table. So this is how the Flannel network works. So it will embed the container IP and encapsulate it with the public IP of the host, and it goes there. When the receiving end receives the packet, it will remove the encapsulation and read the source target container IP. From there, it is going to send that. So here, the encapsulation concept is coming into picture, virtual LAN is coming into picture, overlay network is coming into picture. And here, both the traffics are used, like layer 2 networking and layer 3 networking. Both the networkings are getting used here. So the next network type I'm going to talk about is called Calico network. Okay, Calico network works kind of in the similar way, but adding to that, this networks as an option to exchange the route using BGP protocol. Okay, here also you will have a network daemon that will be running, Calico daemon that will be running, but instead of doing the broadcast, right, it is going to exchange the routing information. So in the Calico network, the network daemon, what it will does, whenever there is a new container comes on the particular mission, it is going to exchange the routing information to the all the other nodes which are connected in the cluster, so that if container A wants to communicate, it already know that it is available on the node B, node 2 of the cluster. So it will directly start routing the packet. So this will be faster than your flannel. Calico is faster than your flannel because it uses the BGP protocol to exchange the route information. This is one simple differentiation between these two networks. Like that, there are multiple other network providers there they have addressed some of the actual issues of the networking, and they have got it further. Okay, so based on your requirement, you need to analyze and choose your network. And for a normal application hosting, you can stick with Calico or Weave. Both of them are better approach.